Hello, everyone. Welcome to the Networking for AI Summit. I'm Bob Laliberte, Principal Analyst with theCUBE Research. And I'm joined today by my good friend, fellow analyst and CUBE Collective member, Zeus Kerravala. Welcome, Zeus.
Hey, Bob, how you been?
I'm doing very well, thank you. And thank you for joining me, because, as you know, we spent a lot of time talking about and watching how AI is developing and it's how it's reshaping IT and networking. We've done some research on the topic as well. And the one thing that we've seen that's very clear is networking is becoming a real critical part of all these AI initiatives. So I'm wondering, if we can get things started today, maybe by talking about the big picture. And from your perspective, why do you see networking being such a critical foundational element for all these AI initiatives that are taking place? And why is this a good time to be talking about networking for AI?
Yeah, it's a good question, right? Obviously, when you look at the rising tide that is lifting supposedly all boats in AI, it's been a lot on the software side, GPUs, but networking really hasn't seen that rising tide yet. But I think networking isn't just important for AI adoption, it's critical in that it's the very fabric that makes large-scale AI work, right? So you can contain AI within a system, but as soon as you want it to go cross-system, cross-data center, across multiple data centers, without a robust and highly performant network, the most advanced AI chips are nothing more than a bunch of isolated AI islands, right? And so that really limits what we can do. And I think when you think about the very nature of AI, it's data intensive, right? And so we're going to be pushing more traffic to more places. Training AI at scale, right, requires a really robust network. Low latency and high bandwidth are now non-negotiable, right? We've got 400 and 800 gig speeds now with Ethernet. And I think inferencing also depends on the network. And so those are all network intensive workloads. I think there's been a lot of focus on the data center network, and I know we're going to talk more about it, but I do think when you look at it, touches all parts of the network, front end, back end, WAN, security, hybrid, on-prem, right? All the entire neat network ecosystem becomes important. And we've seen this play out in the financial markets as well. And I think this is somewhere I'd like Wall Street to understand just the transition that's happening here. I got some notes here. Arista's Q2 earnings, they had an increase of 30.4 or like 30% year over year growth. They attributed a lot of that to AI. Arista, of course, is the high performance leader. NVIDIA, right? They came in with a record-breaking $7.3 billion in networking revenue. Much of that is, all of that's in data center. Cisco announced $800 million this quarter from AI infrastructure. That more than doubled what they estimated to do with $1 billion. HP saw good growth, as did Extreme Network. Even Fortinet talked a lot about AI revenue. So all across that networking ecosystem, we're seeing growth. And I think if you think of the typical hockey stick adoption, we're just kind of exiting the blade and we're about to hit the sharp rise up.
Yeah, absolutely. I couldn't agree with you more. Like I said, we've seen this across all the different aspects of networking. It's not just the data center. Obviously, that's where we're seeing the most growth today, but very, like you said, the extremes, the Fortinets and so forth, also being able to see that uptick in organizations trying to figure out how to collect the data that's going to be used. Obviously, so much of the attention right now is being placed on the data center side, and especially in a lot of the large hyperscalers, but we're also seeing those enterprises start to adopt this technology as well. You see the effort from the Dells and the others, HPEs, to create those AI factories and make it as simple as possible. So organizations are getting those blueprints and so forth for how to...
And that's the key, right? Simplicity now,
Correct. Because again, this is one of those things when you have a massive transition like this, there's not a lot of skill sets that have it. So you're relying on the vendors. The vendors are putting together their blueprints and so forth for how to roll this out. What's going to be interesting, I think, as we go through the day and we talk with a lot of the different people here, is understanding how they play a role in what's happening across, as you said, in the data center, in the campus and branch, in the WAN, even cloud or security as well.
It actually reminds you a lot of the beginning of the cloud environment. When you think about it, it was, the big cloud companies were building their own infrastructure, then enterprises wanted to build their own, and the companies like VCE, the NetApp and FlexPod, things like that, they put these pre-integrated systems together. We figured out how to scale that. Then things became disaggregated. I think the trend will be the same. Right now, we're in that phase where we need these pre-integrated, validated solutions, the AI factories, if you will. Over time, though, it'll standardize and disaggregate.
Yeah, absolutely. Couldn't agree more. So switching gears to talk about the data center a little bit, we've been tracking this debate between Ethernet and InfiniBand. We've done research on it as well, pretty hot topic. How do you see this playing out? What should enterprises be watching for as they start designing their AI data centers?
Yeah, I think, when you think about InfiniBand, it's been the historical kind of king of high performance, right? At ultra low latency, lossless fabric, and very specialized protocol, for specific use cases. So historically, it's been cluster computing, where you couldn't drop a packet, and that wasn't Ethernet's strength. And that's why I think InfiniBand in a lot of ways took the early lead in AI networking. Now, I will say that when you look at Ethernet, the Ethernet vendors have done a good job at adapting Ethernet. And in fact, Ethernet always seems to adapt, right? And our research actually showed that people wanted Ethernet, but at the time we did the survey, which is about 2 years ago, they actually believed that InfiniBand performed better, therefore they were going to buy it. But all things being equal, right, they would want Ethernet. And so with RDMA over converged Ethernet, I think that's a big advancement. I think also the latency has come down, like it's maybe not quite where InfiniBand is, but I know Worldwide Tech did a study where they compared the performance of Ethernet and InfiniBand in training environments, and it was negligible, right? And so now it is kind of really on par. And so I think for companies, I think they need to look at what works best for them, where their talent is. I think they need to understand how to connect gigascale systems at these AI factories at scale. And I think the fact that NVIDIA itself supports Ethernet in a big way is a big indicator that the industry is shifting. I'm not going to say InfiniBand's going away, right? I think from an NVLink perspective, it's it works well, kind of as an embedded technology. But as AI scales, we need Ethernet to do it.
Yeah, I think it's a little premature to say any technology is going away. We still have mainframes, we still have tape,
we still have fiber channel,
we still have VPNs. So all these technologies that people have said, oh, this is going away, right? They still find a way to carry on. So the
growth is capped in Ethernet, in InfiniBand, and the growth will be in Ethernet.
But it was the necessary technology to get things started, to move the needle. And as you said, like an NVLink and so forth, in internals, it still plays a role. I think more and more organizations, they have to, once they get to that point where it's good enough to be able to participate, they would rather have it for the consistency and the operational efficiency across not only the data center, but again, because as we've talked about earlier, this AI initiative is going to be more than just the AI backend data center, right? It's going to be across the campus and branch. And so unifying that management across that, being able to effectively manage it easily, is going to be Ethernet. I remember a talk that a buddy of mine went to. He came back and Bob Metcalf was talking, and he said,
Ethernet,
right? And said, I don't know what's going to come after Ethernet, but I'm pretty sure it's going to be called Ethernet.
Yeah.
So far he's been right. So we'll see if that continues. I think it's going to be interesting. I think one of the other things to look for in the data center space is not only creating the high performance connectivity with the clusters within the data center, but increasingly between AI data centers, as well as power limitations are starting to constrain what people can do within a particular regional data center. So kind of, it's going to be interesting to watch, but I'm looking forward to seeing those data center interconnects popping up as well.
Yeah, well, NVIDIA just announced their Spectrum GS, right, gigascale, which is meant to scale, not just scale up and scale out, but scale across data centers.
Correct.
And that's going to be an interesting evolutionary step, because you think of, in fact, Jensen Huang, the CEO of NVIDIA, talks a lot about this, what a unit of compute is. It used to be, right, a server, then it moved to a rack, then it moved to a data center, but now a single unit of compute could actually span multiple data centers, or you could have multiple data centers look like one unit of compute that you virtualize up into several, right? And so it creates a lot of flexibility for companies to deploy AI how they want it and be able to pull resources from wherever they need it.
Yeah, absolutely. So and I think we're going to see a lot more in photonics and optical coming back into that, enabling that connectivity in the low latency.
Yeah, nobody talked about optical for a while, right? So
kind of, I think we're poised for a comeback. We'll see how it plays out. All right, so let's go from talking about the data center to talking more about the edge. All this AI stuff is great, but it doesn't happen without any data, and that typically, right, the edge is where that's consumed, whether it be campus or a branch environment, things like that, IoT environments. How do you see some of these new technologies like Wi-Fi 7, private 5G, et cetera, a lot of the IoT integration that's happening today? How do you see that changing the way organizations feed their AI pipeline?
Yeah, it's a good question. And people watch this might be going, if this is an AI session, what the heck are we talking about Wi-Fi for, right? But understand that AI is moving to the edge. And what's more important is the data at the edge is moving around. And a lot of these edge devices are connected over private 5G or Wi-Fi. And I think Wi-Fi 7, it's interesting because a lot of people look at Wi-Fi 7 and go, it's just kind of a fancier version of 6E, but it's really the same. But Wi-Fi 7 does have some, I was talking with David Coleman at Extreme about this, who I consider Mr. Wi-Fi, right? We're talking about the uniqueness of Wi-Fi 7, right? 320 megahertz channels, 49 to 6 cam. That's really, that's ideal for like a lot of AR, VR, high latency, jitter-sensitive type of environments. It is more deterministic, right? It's got multi-link operation built into it, which allows you to bond links together. You get better device density as well. And so I think Wi-Fi 7 is an interesting edge technology for, for AI. And that also goes hand to hand with private 5G or private cellular, right? It doesn't have to be 5G. Where unlike a shared Wi-Fi network, 5G is more deterministic in nature. And so historically, if I needed performance or reliability more than performance, I'd go with cellular. And if I needed, better speeds, I'd go with Wi-Fi. But I think the two are overlapping at the edge. But clearly, I think private 5G has a role when you've got where you need that highly deterministic, ultra reliable type of network, right?
Yeah, and I think it also, as you see, a lot of people ask me, where are people deploying private 5G? And I'll always tell them, look for the people who are deploying private 4G, right? And a lot of those tend to be those larger outside, you hear the mining, oil and gas, shipping, docks, facilities, things like that, where it becomes too cost prohibitive to deploy that many Wi-Fi devices and ensure you've got access and coverage. So I think, like you said, I think what we're starting to see, and we're starting to see this more and more, companies like Meter who are deploying both AP in their access point, both Wi-Fi and private cellular as well. So we're starting to see more and more like that. Celona just made an announcement where they made it look an awful lot like Wi-Fi.
Yes.
Right. Cloud management and so forth, distributed devices. So we're starting to see those start to come together. And I think it's really going to be where you need it. One of the more interesting things that I've seen, not so much for AI, but those private 5G are also being used for their neutral hosts. So to be able to extend the connectivity of all the carriers to devices. But I think that's also going to play a role, like I said, with IoT devices, sensors, more and more being deployed all the time, all that data needing to be collected, all that data needing to be inferenced, and all that's going to take place at the edge. So certainly a lot of opportunity for the networking companies to provide those front-end networks to collect all that data, bring it back to an inferencing point.
I do think what's missing right now is the converged management of Wi-Fi and 5G. It's been talked about for a long time. I know some vendors have been monkeying around with it, but we don't have that yet. And the other aspect of Wi-Fi that's going to be interesting to watch is when I was at Mobile World Congress, Cisco was demoing their ultra reliable Wi-Fi for backhaul, which is actually a private 5G replacement. So, so that I do think the good news for customers is whether you want to do a private cellular, whether you want to do a Wi-Fi, the technologies have gotten good enough that you can run AI workloads over it, and you're going to need it because of the volumes of data that you're going to be generating. You brought up IoT, right? Yeah. There's so many more connected devices. In fact, one of the things Jensen always talks about in his talk track is how physical AI is the next wave of AI, right? And so that's a lot more connected machines and moving autonomous vehicles. These are all IoT connected endpoints that are generating just petabytes of data, and we got to think about how to move those around.
And the real-time component of that going to be incredibly important.
Yeah.
You don't want an autonomous vehicle getting something 30 seconds late
No.
when you're walking in front of it. Right.
Or 3 seconds.
3 seconds.
Yeah.
Those could have disastrous consequences. Absolutely. So I think, it's interesting. We've talked about the data center. We've talked about the edge and so forth. But as we've said before, even, once that data is collected, once it's analyzed at the edge, it also has to be moved, right? So if you want to fine tune your models and so forth, you need to come back to those clouds or data centers you're at, right? These are obviously distributed over great distances. So WAN technologies need to evolve as well. What are you starting to see now as that WAN component of the AI space as well?
Yeah, well, you're seeing the telcos actually starting to lean in now, right? Verizon has their AI Connect offering. Yeah. And I think it's important that telcos get involved because they're the ones that help with the global transport. And I think in a lot of ways, they've been on the, there's a few, like Lumen, I think, has done a good job of deploying edge locations and things. But for the most part, the telcos have been on the outside looking in when it comes to AI. But I think their opportunity is to be able to connect things at massive scale. I also think that, again, the growth in bandwidths, right? 400 gig, 800 gig, we got terabit networking right around the corner. We're going to need as much bandwidth as we can get to move the data where we need it. One of the interesting technologies to watch is, it's a little bit of what's old is new again, is WAN op.
Yeah.
Right. And so if I've got to move data from one location to the other, who does that better than the WAN op vendors? And we kind of left WAN op for dead. Right. In fact, Riverbed, who all accounts is just the leader there, has even pivoted a lot of their messaging away from it, but maybe that was too soon.
Well, they actually still have that. And like I said, it's an interesting concept when you think about.
Couldn't tell from the website, though.
All this data being moved now across the web. I think the other interesting piece of it is, so certainly like you said, the telcos are getting engaged. Google just came up with Cloud WAN and so forth. Right. So they're recognizing that there's more data that's going to have to come across. And I think one of the more intriguing pieces for enterprises to think about, it's not just that there's more data, it's what's the impact of that additional data going to have on their traditional applications, their mission critical apps that they're running today, because this is all incremental, right? So if you're thinking about what you've got set up for your WAN traffic today, it's almost, I'll go back, I'll dig down deep into the reserves here, go back to, 2001, 2002, when everyone suddenly had to create disaster recovery plans and they had all their WAN networks. And then they were saying, oh yeah, I need to get this link, this fiber channel link across, but it's okay. I've got, they were confusing the little b and big B.
Oh yeah.
Megabits, megabytes, right? So all the storage people talked in bytes, and suddenly they're needing like OC48 connections, and that being eaten up just by one connection. So I think it's a real good opportunity for organizations as they're thinking about their WAN environment to really start planning over how much traffic or how much data are they going to be generating at the edge, and then how much of that's going to be moved. And then looking at their pipes and trying to figure out how are they going to do that. Like you said, could be an interesting opportunity for WAN optimization to come back in to be able to compress and move that data more efficiently so that it's not impacting any of the mission critical apps that are running over it.
Yeah, it's gonna be interesting to watch too, Bob. But Chuck talked a little bit about this on the Cisco earnings call. Is there a wholesale network upgrade coming, not just in data center, but campus WAN, Wi-Fi because of AI? And we haven't really had a kind of universal upgrade everywhere event since Y2K. Right? Even cloud didn't really do that. And so this might be the first time in a long time that we see companies accelerate their replacement cycle to be able to upgrade the network to be able to accommodate the needs of AI.
Right. And that's where the whole rising tide you started the conversation comes with. As organizations really take a look at what's happening, the transformation that's occurring, the criticality of the network to ensure not only a successful AI initiative, but also to ensure that their mission critical apps remain as optimized as possible and that they're still delivering positive experiences for all those that are in the workplace.
Yeah, in fact, one of the, I do a lot of work in the area of sports. One of the sports CIOs was telling me when they went to 6E, Wi-Fi 6E, they did have to upgrade their campus to multi-gig. And he was saying that he thought the gig network they had in place would have been in place for a long time. But now that you're pushing gigabit connections for your Wi-Fi, the wired network had become the bottleneck. Yeah. Right. And so you can easily play that out. Yeah. Right. With more private cellular, with more, Wi-Fi 6E7, our gig networks are going to need upgrades.
Yeah,
Yeah.
absolutely. So wrapping things up here, I know one of the more interesting areas for us to cover, we've talked a lot about networking for AI, but also how AI is transforming network operations. The research we conducted certainly had some compelling results in that area. What excites you the most about that role of predictive, generative, or agentic AI in helping to simplify network management?
All right, so this is a good question, because as a former network engineer, what excites me most is the move from the traditional human-intensive, reactive break-fix management model, which we have lived with for 30 years, to something that's a lot more proactive, automated, and self-healing. All these buzzwords that we've used for a long time. What we couldn't do, all the vendors tried to deliver it, you couldn't do it without AI, right? And so even being able to just predict when something in the network is going to break, right? So over time, your traffic's trending in a certain way. Well, even the most basic AI model can tell you when you're going to run out of bandwidth. Right. So tell me now, let me go fix it in advance, so I don't have a bunch of users screaming at me telling me that the network's not working, right? So there's the predictiveness. Also, I think generative AI is going to give us that Jarvis-like experience that Iron Man has, where he talks to the network and asks the environment, like, which devices aren't performing properly? Where do I need better coverage in my Wi-Fi? Which devices are most likely to be breached? Things like that. And so now I can get ahead of a lot of the problems that I might have down the road. I can simulate experiences. We've talked about, long before about digital twins and being able to build a digital twin. And so I think all of those things lead to network engineers just being able to work in a much more controlled, predictive environment. So we're not always fighting fires, and that's a very tiring way to work.
Yeah, no, I agree with you 100%. I'm looking forward to, I see agentic as a way to really help coordinate beyond the network. So into security, into observability, into ServiceNow, being able to get those ties into the other domains potentially, so that you can help automate the process a little bit more. I do think what's going to be critical, though, is that organizations keep the human in the loop. I've talked about this a lot, that time to comfort with this new technology. Most of the network admins and operations teams are very conservative. They've resigned themselves to know that AI is here. It's not going anywhere. So how can they best use it? But they also have to validate the technology. They have to make sure that what it's doing is correct. And so there's a time that'll take to get comfortable with the technology. But I think once they do, as long as the human is kept in that loop and that closed loop systems that you hear about, after it will do the automation and validate that it's still operating and letting the people know, I think that's going to go a long way in accelerating the adoption of this. The more transparency they can add to that process. Hey, we just went and talked to all these devices. Here's what we found. This is the next step. Do you agree? Right? And then it comes down to the Tootsie Pop. How many times do you do that before you say, okay, go automate it and let me know afterwards?
Yeah, AI is great at a lot of things, right? Pattern recognition, it's good at it's doing things faster, but it lacks the contextual understanding that people have. And so I think the whole concept that AI is going to replace the network engineers largely unfounded. I think the role will change,
correct,
right? If you're that network engineer that spends, all your time looking through Splunk logs or something like that, that job probably largely gets replaced by people, as it can find those needles in a stack of needles much faster than people can, right? So, but I do think a lot of the trust and oversight and final decision making has to be done by people, because you have the context as to what that is, right? So, for instance, you may want to patch a system on the last day of the month, and you're a bank, right? And so you can't do that when you're trying to close all your accounts, right? So I do think that the job does change, though. And I think every technology transition we have has helped automate more things, right? You think even people said that about cloud networking, right? It was taking away the engineer's job, but now I can provision devices with one click. We have more network engineers than we've ever had, right? And so I think we'll see the same transition, but I'm very excited for the network engineer, because this has been a tough job for a long time.
Yeah, and I think ultimately, from what we've seen in our research, the end goal of AI is to enable these operations teams to work on more strategic initiatives, right? The things that are the harder, more difficult, right? How do we design the network to accommodate all this AI traffic that's going to be coming over, rather than just firefighting common issues, routine issues that keep popping up.
And frankly, there's a lot of unsolvable problems in networking. Like Wi-Fi troubleshooting to me is one of the toughest things ever, right? Is it too many people on the network, too many devices? Is there some malware? Like, who knows? I don't know, right? Wi-Fi troubleshooting is tough. And so let the AI do a lot of that stuff that we spend hours and hours doing that don't really add to our resume. And so the advice I give network engineers is that if you're doing things today that aren't going to improve your resume, find a way to use AI to automate that out of your job. Documentation, stuff like that.
Great. I think that's a great way to wrap up. Zeus, as always, thank you so much for your perspectives and for walking through all these issues with us. Appreciate it. And for everyone tuning in, the takeaway is clear. Your AI initiative success will depend on the network. From GPU interconnects in the data center to wireless at the edge, from WAN evolution to AI-driven operations, the network is the foundation that will determine whether organizations can scale AI effectively. And with that context in mind, we're excited to set the stage for today's session. We'll hear directly from leading vendors about how they're helping customers build future-ready AI networks. So stay with us. It's going to be a great day.